So the first thing to understand when you're installing Lustre, of course, is what you're going to be using it for. I mean, you can configure quite a bit differently depending on your intended use, your throughput. I mean, typically today, people buy the storage for HPC is largely driven by the performance and not very much by the capacity. You know, people will target a given, you know, number of gigabytes a second, and then the space that's available on the disks is essentially always exceeding their target. We have noticed in a lot of different installations, I mean, SAS is performing quite a bit better, and it's not a surprise to hear that LSI is moving all of their enclosures over to using SAS only, because the SATA, while it's less expensive, I mean, you know, it's the extra capacity you get is not worth the reduced performance. Moving on. Quick, the same picture, you know, three main components, the clients, the data servers, and the metadata servers that need to be planned out. So what's important, especially if you're trying to achieve maximum throughput, is to design your system to be well balanced. And I mean, of course, that's true across the whole HPC cluster, but even within the storage system, that's important. On the OSS side, you really do have to understand the architecture of, you know, the motherboard and the controllers, the PCI slots. And if this is all, of course, if you're rolling your own solution, which some people are interested in, you know, there's an increasing number of vendors that are doing, you know, this kind of low-level planning for you. You know, not to name names, but you know, there is a growing segment in the market that is delivering pre-configured solutions where everything's tuned. And I was actually amused and surprised this year at supercomputing. There's, you know, lots and lots of vendors that I'd never even heard of that are selling Lustre solutions. You know, which in some senses that's good. I mean, it means that Lustre is gaining lots of traction. I mean, it's good that they're comfortable to, you know, sell a solution to customers, you know, without having what I consider support, high-level Lustre support. But it means that it's robust enough for them to feel comfortable doing that. But you know, that's a decision that you can make. Obviously, there's a price premium, and at the you know, petascale size, people are looking to save everything, you know, that they can. If you have to pay double for your storage, it may not be worth it. It's hard to say. The memory is on the I/O servers is becoming more important. In days gone by, you could get, you know, it was acceptable to have a minimal, you know, 1 gigabyte, 2 gigabytes of RAM. Lustre is increasingly making use of the RAM on the object storage servers, and modern installations typically have, you know, 24 gigabytes of RAM or more. That's important partly because the size of the individual OSTs is growing so large that you need to have more RAM to cache the file system, like the local block allocation metadata and things like that, the inodes. But also because there's a data cache since Lustre 1.8, and being able to cache data there is important for shared read workloads, you know, clients reading the same configuration files, input files, and things like that. So the memory requirements for OSSs have gone up quite a bit. On the MDS side, you know, typically It's been RAID 1+0. SAS is pretty important here. SATA is not really going to cut it. What's been a big question for a lot of people is SSD worthwhile on the MDS? And it's a little bit of a mixed bag. I mean, if you're just doing a relatively simple benchmark of hard drives versus SSD on the metadata server, you don't actually see very much performance improvement today. There's a couple of factors there. One is that the locking and things like that in the software is not optimized for the low latency of the SSDs. So you hit a peak, depending on your platform, maybe 20,000 metadata operations a second, and that is not really helped by adding in SSDs. The other thing that is important to note is that because Lustre is doing completely asynchronous metadata operations, you're not really using the high IOPS of your SSD device for write workloads, or if you're doing benchmarking and you're doing, create 10 million files in a directory and then stat them and things. All of that with the size of RAM that you have today, your workload is going to be cached in RAM, and you don't see any big performance improvement. With further testing on SSDs, what we've really noticed is that for cold cache operations, SSDs win hands down. You can sustain, the 20,000 metadata operations even from a cold cache. If you're doing that from hard drives, you're really limited by the IOPS of the underlying disk if you have a big enough working set. And that can be a factor of 20 times improvement going to the SSDs, and it's not cost prohibitive given the small relative size of the MDS compared to the rest of the file system. So just as a reminder, on the metadata server, you only need space for the inodes. It doesn't store any data, so that's only 4K per file. And given the average size of files, I mean, if you work this out, on a lot of systems, you're only looking at a few hundred gigabytes of space for the MDS on a big file system. And a lot of people, they were over provisioning their metadata server size, just because if they're using spinning disks, again, you get the more space than you need for the number of IOPS you want to have. And so they were making gigantic metadata servers, and they're never going to fill them up. So with SSDs, obviously, you're more cost conscious, and you want to minimize that size for the expected usage. And of course, you need as much RAM as you can. I mean, that's giving you probably a factor of 10, well, for hard drives at least, if you're not doing SSDs, it gives you about a factor of 10 improvement to get things out of cache versus off of the disk. With SSDs, the ratio is going to be a lot smaller, but still worthwhile. So this is getting into the nitty-gritty. One of the things when people are doing their own Lustre installation is there's two sets of RPMs that can be installed, and it's a bit confusing if you're not familiar with it. On the server side, well, I guess it's might as well follow what it says. InfiniBand, it used to be a lot of work to get InfiniBand working with Lustre. You'd have to, download OFED and all those things. With newer builds of Lustre and the newer vendor kernels, they ship InfiniBand built in, so you can use the included OFED stack, and Lustre, all of the Lustre RPMs ship with the OFED modules built already. So the server kernels, you need to get a Lustre specific kernel, and it's the kernel. You need E2FS progs. the Lustre E2FS progs to support the added features that we have, and the Lustre modules and LDiskFS. On the clients, you only need the 2 RPMs. You don't need to install a patched Lustre kernel on clients anymore. This has been true for a couple of years, but it's important to mention so that you don't need to install this other stuff, kernels, E2FS progs. You don't need any of that on the client, and it's right now we're supporting on the clients is supporting the main vendor distros. RHEL 6 is just under development and coming out in the next couple of months, and I think that's something that people are going to be interested in the near term. So another area that people raise a lot of questions on is with Lustre running on InfiniBand, is it using IP over IB? I mean, it does need IP over IB installed, but it only uses it for doing address resolution. The Lustre, when you're configuring Lustre, you specify the node names or addresses. I've shown in my examples, I should just show IP addresses, but you can actually use node names, and if they resolve in DNS properly, and it translates it to an IP address, and then at startup time it contacts, uses IP over IB functionality to resolve the GUID addresses internally, so that you don't have to be tied to, if your IB card fails, you need to switch it out. You don't want to be storing those addresses anywhere internally. So it does need to be there. It doesn't use it for any kind of data transport or RPCs. So unlike TCP, if you're setting up a very simple Lustre system with a single TCP adapter, Ethernet adapter, it will work out of the box. If you're using InfiniBand, you do need to tell Lustre to use the O2 IB driver, and it will, if you have multiple InfiniBand networks, it is possible to set up multiple IB HCAs, but currently it's only partly supported. It doesn't do load bandwidth aggregation across multiple IBs. Across multiple HCAs. It will only do use a primary adapter for any given host, unless that one fails, and then it will fail over. Some little tuning tips if you're doing, this is just for the InfiniBand stack itself. The message-based interrupts gives you a bit better performance, and if you're using IB on the storage side, I mean, this is sort of agnostic. I mean, Lustre is not specifically driving the storage itself. It's the SRP or whatever at the lower level that is just exposing a block device, but it's still important for Lustre performance to allow full 1 megabyte I/O size to go directly down to the underlying disk. So I thought it's worth mentioning. If you set the SG table size, it allows you to do 255 different fragments, which is important. I think the default's 32, and it can give you bad I/O performance at the disk level. Moving on, a bit of a example. I mean, with the advent of InfiniBand, people are setting up routed networks more often. That's becoming popular because you want an InfiniBand network within your cluster, but you don't, have the budget or the infrastructure to have InfiniBand across your whole campus. So you have a 10 gig backbone or something like that you connect to, and so having Lustre be able to be accessible from multiple clusters. Or from workstations that are not part of the main cluster. It's interesting to have a routed network. So I thought I'd throw up an example here. So on the client nodes, these clients here are Ethernet connected. So it's this configuration line is saying that these clients are connected with TCP, and in order to get to the IB network 0, they should route through these IP address for the routers. Conversely, the server nodes here in this example are connected on InfiniBand. Maybe they're part of a bigger cluster that's directly attached, and they're using IB network 0. So of course, if you have multiple IB networks, this would be O2 IB1, O2 IB2, etc. And they're saying to get to the to reply or connect to the TCP0 network, which is not to be confused with the Ethernet device 0. The TCP0 is just a Lustre name for one Ethernet segment. One IP subnet, really. To route to TCP0, go through these router. Did I set this up right? To get to these addresses on TCP0, go through the IB0. I think. I wonder if I set up this example incorrectly. I would apologize. The router nodes, they need to have obviously both Ethernet and InfiniBand adapters, and so they're saying you're going to set up on the router nodes specifically both a TCP0 and an IB0 network, and they will be forwarding traffic. And then because the router nodes, because the router nodes don't have Lustre mounted on them, they don't do automatic node startup themselves. So you need to have a little startup script that loads the Lustre module and sets up the routing for you. So in Lustre, one of the things that we've really noticed is that Lustre is blamed for a lot of things because we sit on top of a very tall stack of other components. At the client side, you have the client, you have the network between the client and the routers, maybe the router node, the router to server network, the server nodes, the server to storage network, and then finally the storage, controllers and everything behind that. And so when there's a failure anywhere along there, they say, okay, well, Lustre's not working. And so we built a diagnostic tool called LNET self-test, which can be run as soon as basically you've installed the LNET module and configured the low-level networking for Lustre, and it allows you to do stress testing of whatever type of underlying network that you have installed. And we've found in quite a few cases that Lustre stresses the underlying network at least as well as the vendor tools, diagnostic tools do. And there was sometimes we'd be running this, and the vendors would say, "Boy, we never got all the lights on solid like that before. So it really pushes the network pretty hard. And unfortunately, I mean, given the short time of this presentation, there's not a big example here, but it's very simple to run and very well documented. But I just thought I'd mention it in case you'd never heard of it, that this is something to run, when you're just setting up your cluster, even before the storage is configured, so that you can drive a load and make sure that your cables and what have you are connected up properly, that your routing, your addressing and everything is correct. To go on, setup of the metadata server and the management server is pretty straightforward. You format, the underlying file system. It can be, like I mentioned before, Lustre runs on any kind of underlying storage, be it hardware, software, RAID, whatever. So it's desirable these days, and we recommend that the management server have a separate storage device. It can be, LVM, just a small partition, but it gives, if you ever expand your file system in the future, it's just easier to have it on a separate device. I mean, we do also allow the management server to share a disk with the metadata server, because it only needs, 100 or 200 megs of space. It's not very much, but it's just easier for configuration to have it separate. And the metadata server, if you're doing things like SSDs, you're really trying to minimize the amount of space that you allocate on the metadata server to maximize the number of inodes that you get. I've shown an example from the manual, but if you can specify a parameter to say, give me one inode on the metadata server for every 2K. The default is every 4K. The lowest this can reasonably be is about 1.5 or 1K per inode, but 2K is pretty safe, and it lets you use more of your SSD space more efficiently. And you can mount this on a small system. You can do the Lustre mounting, essentially all the server startup from your FS tab. It more typically, if you have a HA manager, Red Hat Cluster Manager or whatever, you don't put anything in your FS tab and you just have the HA manager do the startup for you. And it's, we provide sample configuration in the manual for how to set up Lustre with the HA manager. And it's because we do all the startup and shutdown with mount and unmount. It's just the same as setting up a shared NFS HA setup, and that's very standard in pretty much any HA manager you can get today. Pretty much the same on the OSS. One thing that we can't do ourselves, because we have to ship a default configuration that works for everybody, but if you know that your file size is going to be large, you really want to create only enough inodes on the file system for what you're actually going to be using. So if you know you have 1 megabyte or 4 megabyte or 20 megabyte average file size, you can really speed up your FS check time. The other good news is with the move to ext4 file systems, a lot of the newer features have really improved the FS check. There's a test 1 terabyte file system on a single SATA disk that was filled completely, I think 50 million files, and it can do the FS check in 5 minutes. And so, it's actually pretty fast these days. And so a couple other options. So this says use the ext4 enhanced features, which is good. You need to make sure that you have the ext4-based LDiskFS module with it. This increases the average file size and in turn, reduces the number of inodes you get. An increased journal size is important at very high throughputs, like you get with InfiniBand, because you don't want your file systems, the server blocking, waiting to commit transactions to disk. So if you have enough space, enough RAM, you increase the journal size. It gives you a reasonable boost of performance. And you mount the Lustre file system on the OSS, and you essentially have a working file system at this point. The clients, they all mount the same. You give it I should have actually typo here, MGS node. Give it the MGS node name, and mount point, and it will mount your file system. LFS-DF is a simple command that I run all the time just to tell me that the file system's up, that you're connected to all the servers properly, and everything as well. Brief introduction to Lustre troubleshooting. I mean, some people will be doing this themselves. Some people obviously will have a support provider that they can talk to, or the mailing list, of course. But people will report a problem to us and say, oh, the client doesn't work, or my application doesn't work. What's wrong, right? And so you're not going to get anywhere if you don't look at the system console. So that's either dmessage or varlog messages. It will print on the client and on the server, relevant error messages to help you diagnose problems. Of course, the first errors are almost always the most useful. You're not going to get anywhere with the next 20 megabytes of error messages. But some things that people often do is they'll send us, just the Lustre error messages. And it's important to include things, like if there was immediately preceding InfiniBand error messages or SCSI error messages, things like that, out of memory, stack traces, that kind of thing. If you have a good infrastructure, you can have serial consoles on the servers. That's incredibly useful if you're using Conman or some other infrastructure to log messages like that. And with most new server class, nodes, they'll have IPMI or Ethernet serial consoles that you can configure. And as mentioned previously, IB cables can be very sensitive. So, if you're having problems where your nodes are losing communication on a regular basis, that's really the first place to look. And because Lustre drives the network very hard, it can sometimes, show problems that you won't find elsewhere. And that's mostly it. I left some good time at the end for questions, if people have questions they'd like to ask.